Alright, so now in this lesson, we're going to cover one of the most important concepts in networking, the OSI model. Alright. Many people memorize the OSI models for exams, but very few actually understand it. Right, so if you truly understand the OSI model, troubleshooting stops being a guesswork and it becomes logical. So it exists to explain how data moves from one device to another in a structured, predictable way. So it breaks networking into layers so that problems can be isolated, uh, designed and fixed systematically. So think of an OSI model as a map. Without it, you are guessing. With it, you know exactly where to look. All right. OSI stands for open I don't know where is it. All right, that's fine. So it stands for open interconnection, open systems in interconnection. It's a conceptual, it's a concept, right, model that describes how data moves across the network in 7 distinct layers. Each layer has a specific role. Each layer depends on the layer below it. So the OSI model is not a protocol, it's not a device, it's not a software, it's a concept. It's a framework that is used to understand, that is used to design and to troubleshoot networks. So even though real networks don't strictly follow the OSI model, the model is still used every day by technicians, by engineers, by vendors. Now, why does it use layers? Before I can. All right, so why does it networking use layers at all? Imagine trying to fix a problem without a structure, so you wouldn't know where to start. Layers allow us to separate responsibilities. Each layer focuses on a specific task, such as a physical transmission, or addressing, or application communication. So if a problem occurs at layer 1, we don't need to inspect every part of the network, we just narrow it down. This is why layered models exist in all engineering, um, disciples. Now, the OSI model consists of 7 layers from bottom to top. They are physical, data link, and then network, transport session, presentation, and application. Data starts at the application layer on the sending device and moves down the layers. Right. So on the receiving device, data moves up the layers in the reverse order. Each layer adds or removes information as the data passes through. Now, layer 1, which is a physical layer, this layer deals with the actual transmission of raw bits, zeros and ones. All right, so it includes cables, includes connectors, voltages, light signals, radio waves, and timing as well. The physical layer does not understand data, addresses, or applications, so it only cares about whether a signal exists or whether it can be transmitted. All right, so if a cable is unplugged, damaged, or maybe a signal is too weak, then the problem is at layer 1. Some typical layer 1 issues includes broken cables, wrong cable types, damaged ports, and signal interference. And then now, layer 2 is a data link layer. This layer is responsible for moving data between devices on the same local network. It uses physical addresses called MAC addresses. So switches operate primarily on this layer. So the data link layer also detects transmission errors and controls how devices access the network medium. So if two devices are they are on the same LAN, all right, layer 2 is responsible for delivering the data correctly. problems such as incorrect VLANs, MAC address conflicts, or switching loops, all of that occurs on layer 2. Now, layer 3, network layer, this layer is responsible for logically addressing and routing, right? It uses IP addresses to identify network and devices. Routers operate at this layer. The network layer decides the best path for data to take from the source network to the destination network. If devices are on a different network, layer 3 is required to move data between them. So routing issues, incorrect IP addresses, missing routes are all layer 3 problems, right? Now layer 4 is a transport layer. So this layer is responsible for end-to-end communication between applications. So it controls reliability, flow, controls, and error recovery. So there's two common transport protocols, are TCP and UDP. Right? TCP is reliable; it checks that the data arrives correctly, and then UDP is fast, but there's no guarantee. There's no guarantee of delivery. Right? And port numbers operate at this layer and allow multiple applications to communicate simultaneously. So if a service is running but unreachable, the issue is layer 4. Now layer 5, session layer. This layer is responsible for establishing, maintaining, and also terminating communication sessions. So it manages conversation between devices. Right. So if a session drops unexpectedly or cannot be re-established, the issue may be at this layer. Although modern protocols often combine this layer with others, so the concept is still important. And then layer 6 is the presentation layer. So it handles the data formatting, encoding, and compression, and encryption. So it ensures that data sent by one system can be understood by another. Right? Encryption and decryption occurs here. So if data arrives but appears unreadable or encrypted incorrectly, the issue may exist at the presentation layer. Then finally, the last layer, which is layer 7, the application layer. This is the layer that is closest to the user. So it includes network services such as web browsing, email, file transfers, and remote access. So this layer does not include application software. I'm not talking about Microsoft Word or Excel or any application that you may be thinking of, but I'm talking about network services like web browsing, like email, like ICMP for email, POP3. So all of those will fall under the application layer. And then remote access like RDP. If a website is down, email cannot send, or service refuses connection, the issue may be at layer 7. Now, let's put it all together so that you understand. Okay, before we get there, so let's actually put it all together. So when you open a website, the request starts at an application layer, right? It moves down through the presentation, session, transport, network, data link, and physical layer. The data crosses the network, and then on the receiving device, the process happens in reverse, right? Each layer performs its function and passes the data upward. So this structured flow is why networks scale and work reliably, right? Now, the OSI model is the most powerful when troubleshooting. Instead of panicking, you just ask structured question. Is there a signal? So that's layer 1. Normally at the back of a computer there is a signal light, right? Normally it's green or flickering orange. So you check, is there a signal? So that is a physical layer. Can the device see each other? So that's layer 2. Okay, so we can ping. Can they reach other networks? So this layer 3 can ping maybe the other router. Is their service responding? responding rather. So that's layer 4 through 7. So this approach saves time and it prevents guesswork. All right. So the takeaways, just to summarize, the OSI model breaks networking into 7 logical layers. Each layer has a clear responsibility. Understanding the OSI model turns networking into a logical system. Right? Memorizing without understanding is useless. So mastering this model will make you a stronger technician. And then next we'll explore ports and protocols. So this builds directly on the transport and application layers. So once you understand how services communicate, then networking becomes predictable.